Let's do this thing, physics. Y'all have a quiz coming up. I asked y'all to do these questions. Right, there's 15 of them. There's 4 pages. I'm going to go through all of them. These are all like pretty typical of what you would see. So, I don't know. Let's just jump right into it. First question, I actually really like the first question because it's not that much math. It's basically just physics. Like, do you know the physics behind the thing? You have a projectile launched at some angle above the ground. They don't tell you what the angle is, but they tell you it's some angle. A horizontal component is 40 meters per second. Vertical component is 30 meters per second. So what they're telling you here is that this is 40, this is 30, right? I could figure this out if I needed to, but I don't for this question. What is going to happen to the velocity after 2 seconds? Right, some of the things you have to remember, the biggest thing that you have to remember is that for any projectile, right, x and y are independent of each other. Next thing is that x acceleration is 0, which means the x velocity won't change. So I can eliminate this and this. Those are bad answers because they tell me that the horizontal velocity is changing. Right. Y velocity is 9.81 meters per second squared down. That's the acceleration due to gravity. So I know the y velocity should change. It starts at 30, so this is not good. That leaves us with only one option, right? I didn't do any math. I didn't use any formulas or anything. It was just, what do you remember about projectile motion? Right. Second question is actual math, though. Soccer ball kicked on a level field, initial vertical velocity of 15 meters per second. So we're talking straight up at 15 meters per second. So I know initial velocity is 15. I know the acceleration is negative 9.8 meters per second squared. Hang on. I gotta zoom in because it occurs to me that it's 9.81. So let me be a little more exact. 9.81 meters per second squared. It's negative. Right. Assuming it lands at the same height from which it was kicked, the total time for the ball in the air. This is sort of difficult. It's actually easier for me to go to the top because I know something special about the top. I know that the final velocity is 0. So I can find the time to the top. If I do that, Vf is Vi plus At. Right? I plug in my numbers. I would get this much time to the top. But if I need to get the total to multiply it by 2, that's choice C. All right, 3 seconds, give or take. 4 projectiles A, B, C, D were launched and returned to level ground. If I need to find horizontal distance, then I know that this doesn't matter to me at all. It just doesn't make any difference, right? Vertical does not affect horizontal. So I need to take the horizontal speed times the time of flight, whichever one's the biggest, which by the way is choice D. That's the answer. Let's take a look. Ooh, runner. There we go. Here at number 4, a student standing on the roof of a 50-meter high kicks a stone at a horizontal speed. So I have a horizontal speed, so I have an x information, y information. Vi is 4, Vi is 0, acceleration is 0, acceleration is 9.81 meters per second squared. My change in distance is something. My change in distance is 50 meters. How much time to reach the ground? So time to reach the ground. So I'm looking for this time because we're doing how far is it falling, which means change in distance is, oh goodness. All right, let's do this right. Change in distance is VIT plus 1/2 AT squared. Because this is 0, that goes away, so I'm just doing this. If you do the math, and to make sure that you remember this squared, you get 3.19. If you don't remember the squared, you're going to get choice C. Be very careful. If you don't remember the half, you end up with B? You might end up with B. I don't recall exactly. If you don't remember the half... Actually, if you don't remember the half, you get the wrong answer entirely. So that's less of a problem. At least this time. Alright. Last one on the first page. Projectile is fired with an initial velocity of 120 at some angle above the horizontal. The initial horizontal speed is 55. Alright, this is what they're telling me. Here's the ground. I'm launching at some angle, which I don't know, but I know that this is 120. I also know that this right here is 55. Now I have most of a triangle. If I finish the triangle, right, this is a right angle. So I know I have the angle, I have the adjacent side, I have the hypotenuse, that's cosine. Cosine theta is the adjacent over the hypotenuse. If you need to figure this out, you gotta do theta is the inverse cosine of 55 over 120. Right, you can do it that way. It's actually the only way. This is as weird as this question will show up. It's unlikely to show up, but I just wanted to show one where you do have to look at the inverse cosine or an inverse sine. But that's the information they're giving you. Initial velocity at an angle means that 120 is this, and then horizontal speed is 55. That's down here. Oh my gosh. What the heck was that? Alright, it's fine. I wanted to zoom out anyway, but that was a weird way to do it. Moving on. I really like number 6 because it's all physics. Right? What's going to happen is that we're going to launch ball A horizontally, and we're going to drop ball B. We're ignoring friction. So, ball A cannot travel at a constant velocity. Choice A is no good. Choice B, if I look at this, they hit the tabletop at exactly the same time. In class I tried to do this, and if you check the internet on small scale experiments, this will work. You can try it at home. Get 2 tennis balls, 2 baseballs, 2 things that are the same mass, ideally circles, right? You want them to be, or spheres, I suppose. You want them to be spheres. Put one on a desk or on a table, on a flat surface, hold the other one at the same height, right? Hit one sideways and drop the other one, and see how many bounces you hear, right? You'll hear just one because they are falling from the same height. So number 6 is actually choice B. The reason for that is because neither of them has any vertical initial velocity, and they fall from the same height, right? A is going completely horizontal, B is not moving at all. So when they hit, they'll hit at the same time. Right? There were some people who were like freaking out a little bit because we're on the moon here. It's okay. It's not a big deal. We know that a change in distance is 6 meters. We know that the time is 2.7 seconds. What's the acceleration? Well, we're dropping the hammer, so the initial velocity is 0, which means I can do change in distance is initial velocity times time plus 1/2 at squared, and if I do that, plug in the numbers, you get choice A. Again, number 8 is exactly like number 6, but one of them is going twice as fast as the other, so it will go twice as far, but they'll hit the ground at the same time. So both spheres hit the ground at the same time, but sphere A lands twice as far as sphere B. Alright. Now, looking at number 9, a baseball is thrown at an angle of 40 degrees above the horizontal. So here's the horizontal. I know that this is 40 degrees. And it tells us the horizontal component. So this piece down here is 12 meters per second. I want to know what was the initial, so what is this side? Well, again, I have this triangle. I have the adjacent side, I have an angle, and I have hypotenuse. So cosine of 40 is the adjacent side. Oh, don't do it. Unbelievable. Cosine of 40 is the adjacent side, 12 meters per second, over the hypotenuse. I'm just going to call it x. So if I do this, x is 12 meters per second over the cosine of 40. And I believe the answer was 15.7. It's 15.6 repeating. Again, making the picture, really important part there. Number 10, again, pure physics. We're driving off a cliff, horizontal component, horizontal component. What we said in number 1 and number 8 and number 10, or number 6 and number 8, was that the horizontal component does not change. Boom. Done. We call it a day. Soccer player kicks the ball with an initial velocity of 10 meters per second at some angle 30 degrees. Okay. So we have the ground, we have a 30-degree angle, and we have 10 meters per second. So at this point, it's they're asking, what is this side? Now your reference tables has something that looks like ax equals a cosine theta. So if I make the a's the velocity, then I just plug in numbers. 10 times the cosine of 30 should be 8.7, I think 8.6 repeating, so rounding. Alright. Projectile is launched horizontally. Okay. So I have a horizontal speed. I'm going to start separating information. VI is 30 meters per second. Launched horizontally means that this is 0. I know that the change in distance is h. I know that the time is t. Uh-oh. Looks like I don't have enough. Oh. They gave us time. Time equals 2.5 seconds. Acceleration equals 0. Find this. Alright. Delta d is VIT plus 1/2 AT squared. This is 0. 30 times 2.5. is 75 meters. There it is. Now, notice this wording right here. Show all work, including equation and substitution. So here is my equation. Here's my substitution. I have units here. That's everything that I needed for that question. So you're going to get everything. If you don't have this part up here, and you only do this, and you do this, you'll get 1 out of 2 points, because you didn't show units with your substitution. Alright, because I threw the units into my little table, I know that 30 must be 30 meters per second, I know the 2.5 must be 2.5 seconds. So just make sure that you list the units at least once. Alright. Excuse me? Hello? Thank you. It's gonna do it again, isn't it? Oh, no, it's not. Okay. A kicked soccer ball has initial... Okay. Angle of 40. So I know this is 40 degrees. I know this is 25 meters per second. Calculate the vertical component. So I need this. Alright, so it's a right angle. I know that Vy equals V sine theta. That's straight off the reference table. And again, now I can do it, right? And I can use the correct numbers when I do it. 25 times the sine of 40, which is something that I don't know off the top of my head. Calculator to the rescue. Calculator. Phone to the rescue, really. 25 times the sine of 40. 16.1. So this is 16.1 meters per second. There it is. And again, I did this, right, because in my picture, if you look, I have this and I have this. There are units, meters per second and degrees. Last 2 questions, just more physics. How does the magnitude, again, remember that magnitude just means size, right? But the vertical at point A, vertical at point B. So how fast is it falling here, compared to here? Right. So vertical at A is less than the vertical at B. The reason for that, as it falls, it's going to keep going faster the more it falls. So if it's only been falling for this far, right, for that far, it's only been falling for this long, it's not going to be going that fast. This one has been falling for this far. It's been falling for this much time. It's going to be going much faster. All right, number 15, horizontal at A, horizontal at B. Horizontal at A is equal to the horizontal at B. All right? Now, these are very typical of what you will see on the quiz. Please, if you have questions, if things were still confusing, I hope that you will reach out. Otherwise, I will see you on Monday or Tuesday, I suppose, whichever. I don't even know what letter day it is at this point, but I will see you then. All right? Take care, kids.